Okay, everyone. So we've made it. We've steadily entered intermediate territory. And although this running document is somewhat more detailed than the early presentations in the series, the introductory presentations, it is still quite abbreviated. In fact, it's extremely abbreviated. There are all kinds of terms and statements that we have to temporarily pause it and then gloss over their explanation, detailed elaboration. Because, first of all, I just don't have the time to put together a more in-depth running document. I pretty much type each session in, say, 30 minutes to an hour, and then I present it. Now, I'm going to try to stick to the running document and not add too many addenda so as to compress this presentation. I'm trying to keep these presentations to around 30 minutes, 30 to 45 minutes. Anything longer seems to exhaust our attention. 30 to 45 minutes is probably the most reasonable span of time that I can expect novel information to be coherently integrated. Okay? So we began with, in the previous segment, the self-dual formulation of physical or definition level syntax. Now we're elevating to the logical, mathematical, or description level syntax, relation-oriented syntax, whereas physical syntax is element-oriented. And we call it definition level because every definition requires an element, and every element, whether it's notational or material, has to, and of course, notations are actually material in the sense that you need some kind of physical instance to denote an abstract object, are required for any kind of definition or identification. Now, any definition, however, requires there to be non-trivial properties or predicates of the element. And these predicates are descriptions. And descriptions are logical mathematical for the reasons that follow. Now, remember, we're dealing with every single level of syntax here. These are sub-syntaxes of the emotelic syntax. And we're dealing with self-dual elements called syntactors, self-dual relations called telons, and self-dual operations, namely conspansions or generative syntactic operation, and telic recursion or selective semantic operation. So actually, this is an extremely parsimonious, maximally parsimonious system. The CTMU is that. And we're going to continue to use its terminology for that reason. So, just reminding you that self-dual elements in a physical sense are physically instantiated or bundled syntactors. Their relations are physically sequenced or terminally encoded telons, where telons are utile syntax state relations, which are basically axiom theorem relations in the context of this generalized logical mathematical syntax. And self-dual relations are physically parameterized conspansions and telic recursions, where once again, conspansion is a generative operation. It's an n-ary generative operation, and telic recursion is a unary selective operation, which is terminally oriented towards in selections of physical states, and conspansion is oriented towards retractions of physical states, converting them into potential states, which then telic recursion, I say then to, as a training wheel term, because obviously we're not dealing with just linear time, but which then telic recursion converts into, reselects into new physical states. Now, the self-dual elements of the LMS, the logical mathematical syntax, are mathematically validated syntactors, meaning that every physical instantiation has to be mathematically valid. Okay, that's a trivial condition here, right? In the sense that every single physical instantiation must obey, for example, the Boolean exclusion of two-valued logic. You can't have an element and a complement merge. You can't have a physical object and its space merge. They have to be distinct on the object level. They have to be two-valued on the object level. So that's the simplest mathematical validation of a physically instantiated syntactor or body, right? The compositional structure of mathematically validated syntactors inheres in immaterial material products, and where the products are decidable and undecidable theorems. where decidable theorems are basically algorithmically executable and exhaustible, which in algorithms are finite step executive procedures. They're mechanizable. We can say decidable is mechanizable, undecidable will be non-mechanizable or generable. Okay, so we'll get into that in a little bit. These are the terminally encoded states or products of subatomic, atomic, molecular, cellular, histological, organological, physiological, familial, social, up to celestial and cosmological syntactors, and they are adjoint theorems. So a terminally encoded state, a physical state or body, is an adjoint theorem in the non-terminal domain. Okay, you're adjoining that physical state seems transient, but actually you're adjoining it to the non-terminal domain as a theorem, and therefore that physical state is preserved in N. It's validated in T, and it's preserved in N. Terminal encodements, in other words, are adjunctions of theorems to N. Okay, now again, every body in T is a physical or terminal encodement, and it doubles in a self-dual sense as a theorem in N. As an adjoint, it adjoins a theorem, a dual theorem to N, which is technically the abstract preservation or replication of that body, the structural preservation of that body, where abstract and structural are synonymous here. In short, every state in T is, aka isomorphic to, means isomorphic to, a true statement or theorem in N. So an easy adage that you can use to remember this idea is that every state is a statement. Every physical state is a valid statement. The state is in T, the true statement is in N. The state is a terminal encodement, and the true statement is a non-terminal entanglement. Okay? Now, the class of adjoint decidable, that is, where decidable means exhaustively verifiable by a finite step executive procedure or algorithm, as mentioned, theorems, is isomorphic to the class of states whose terminal encodement is 1, truth valuable, meaning a truth value can be assigned to it as a bound occurrence within a syntactically well-formed formula, and 2, is unambiguously describable in terms of semantic predicates. So to take a simple example, the definite end state of a cytokinetic cycle, being the cleavage of 2 daughter cells, is an adjoint decidable theorem in that it satisfies 1 and 2. It is a truth-valuable bound occurrence, namely, we can observe the cleavage of these 2 daughter cells, right, through our different sensory enhancements through instruments, and this occurrence is unambiguously describable in terms of semantic predicates, meaning its properties are meaningful in a scientific context. We're not utterly confused at what we're observing when we're observing the occurrence of this terminal encodement. Okay, the occurrence of a terminal encodement would be a free or bound variable. In this case, a bound variable, a bound occurrence of 2 objects. Okay, which are the cleaved cells. Note that while such a statement respecting the Tn coupling is verifiable as being bound and interpretable, right? Bound meaning it is observable, and interpretable meaning it is understandable as a scientifically meaningful event. This is surface level capacity, which is in no way synonymous with generable, meaning that a finite step executive procedure cannot generate, or for that matter, physically replicate a cytokinetic cycle or any. This is why physical computations are a subset of physical constructions, and physical computers are a subset of physical constructors. So constructor theory embeds computer computational theory, because physical computers can only simulate and not physically replicate. However, physical constructors cannot generate. You need a proto-computer or a syntactor to generate an end state. So an algorithm, whether it's computationally or constructionally instantiated, can merely verify or check a state's terminal boundedness and interpretability. This is why we classify these decidable theorems as adjoint. Okay? There is a class of adjoint undecidable, meaning non-terminally generable by an infinitary. Note, we refrain from using the term infinite step so as to avoid linearizing the intrinsically non-linear structure of infinitarity processor. So we have non-terminally generable, undecidable theorems are non-terminally generable by an infinitary processor, which corresponds to the non-terminal entanglements which 1. Generate and 2. Preserve all terminal encodements. Accordingly, from the description level vantage of LMS, where the material products or states which are recognized and replicated in the terminal domain T are adjoint decidable theorems, adjoint undecidable theorems are their non-terminal entanglements. Okay. And this leads us to getting into the self-dual relations. But first, a few definitions, right? Terminal encodements are syntactically well-formed and semantically describable statements. Okay? Which are states in T, statements in N. Example, the end state of a cytokinetic cycle is bound and unambiguous in its terminal occurrence. Non-terminal entanglements are syntactically proto-formed and semantically multi-describable statements. For example, the end state of the same cycle is entangled forms a telon with the end states of neighboring or remote cytokinetic cycles which correspond to non-cancerous, cancerous, non-deficient, deficient, etc. daughter cells. So we're adding different semantic predicates to the end states, which means that the end states can be non-terminally entangled via the predicates. In other words, each end state, once encoded, acts as an open parameter of an organism's telic recursion, remaining responsive to higher order telons, meaning denser relationships with denser utility and processed by higher orders of syntax. In a self-dual syntax, meaning definitional, descriptional, and interpretational, abstract objects, like the ones you see here, numbers, members, scalars, vectors, matrices, tensors, variables, groups, etc., proof-theoretic objects, are now the free or bound variables of adjoint decidable and undecidable theorems. This should be no surprise, given that any abstract object is isomorphic to a free or bound instantiation of one or more quantifiers, beginning with the existential and universal quantifiers, which are actually dual to each other under negation. So, mathematical objects, once again, are free or bound variables of adjoint decidable and undecidable theorems, where decidable theorems are technically trivial and undecidable theorems are non-trivial. Okay? Which is why there's, infinitely many more undecidable theorems than decidable theorems in a mathematical sense. Now, self-dual relations are mathematically distributed telons. In this case, they are minimal and adjoint axioms. That's the relational structure of LMS consists of minimal and adjoint axioms. Insofar as all non-minimal abstract relations, like the ones you see here, distances, angles, spaces, structures, expressions, equations, categories, are creatively stipulated but unproven, they amount to adjoint axioms. Mathematicians formalize their abstract systems, logics, algebras, geometries, topologies, etc., through a set of minimal axioms which function as initial, unproven premises, so named because they are the simplest relations to which all denser relations regress. For example, we can invoke many examples here, but set theory contains the axiom of extensionality. For any sets A and B, if for every set X, X being a member of A, if and only if X is also a member of B, then A equals B. Informally, this means the identity of a set is solely determined by its elements, such that two sets which contain the identical elements are the same set. They reduce to the same set. That's the axiom of extensionality. It's an unproven relation between two, or in fact, infinitely many sets on the basis of their shared identity. Okay, now, first question is, why is this axiom unprovable? Or, there's subtlety here. It's unproven. That doesn't mean that it's unprovable. In fact, its coherent or valid definition can constitute as can become a meta-proof in a self-dual context. And we'll get into that later. That's a little bit too technical for this segment. You got to get through more intervening material. Denser set theoretic relations are ramified from the application of set theoretic operations to the minimal axiom set. When proven, that is, terminally encoded, whether by direct mathematical annotation or material construction, such relations become adjoint theorems and therefore immaterial material or non-terminal terminal products, doubling once again as generative entanglements and selective encodements. Normally, definitions are not conceived as axioms despite being unproven conceptual and notational stipulations. Axioms such as extensionality, regularity, pairing, union, and so on qualify as minimal conceptual definitions which carry implicit notational definitions, which is, these sets A and B, X being an element, the membership relational symbol, if and only if relation, the equivalence operator, etc. These are all notational, that they have implicit notational definitions, which we didn't spell out here because we assume that you can understand them through their conceptual definition. But physical relations native to physical syntax, distance, duration, etc., are physically sequenced, terminally encoded telons or adjoint theorems in T and emerge as nested timelines of physical states. Right, the nested timelines of the atomic states, the molecular states, the cellular states, and so on in our bodies are terminally encoded telons in T and adjoint theorems in N. Okay. So I should actually say here that this is in T, adjoint theorems in N. We always want to remember that T and N are also self-dual, technically superposed. Note that the relations of physical syntax, which are, terminally encoded states, terminal expressions basically, are the elements of logico-mathematical syntax, hence providing an isomorphism between these subsyntaxes. Further isomorphisms exist along these lines. For example, LMS relations are the elements meaning the NT entangling percepts of QPS, qualio-perceptual syntax, and QPS relations are the elements of ETS, or emotelic syntax. And we'll detail these ascending isomorphisms in subsequent segments of this series. But basically what we're doing is, again, breaking the vicious cycle of non-recognizing, right, ignoring, being ignorant of the subsyntaxes which go beyond physical syntax and mathematical syntax. These are pretty much the only two syntaxes that we recognize academically, and we ignore the perceptual and emotional or teleodynamical levels of syntax, which are required to respectively interpret and motivate the definitions and descriptions of our science and mathematics. All right, so, and the way we do this is by temporarily, provisionally disjoining these subsyntaxes and then demonstrating their intrinsic isomorphisms through the identifications of their relations, LMS relations with QPS elements, right? STOS, space-time object syntax or physical syntax relations with LMS elements, right? The relations, once again, physical relations, physically sequenced telons in T are adjoint theorems in N and emerge as nested timelines of physical states. Okay, so it's going to take time for this to sink in because, yes, the terminology is a little bit novel and it's a little bit dense. But, again, once we internalize the terminology and the overall language, biopathy will become intuitive and we can start speaking more freely about catalytic interpretations of illnesses, injuries, and systemic malfunctions, which is ultimately what we want to do. All right, so self-dual transformations, or the operational structure of the LMS, are mathematically preserved conspansions and telic recursions. These are nonlinear, I should say here, metaformal processes. They're axiom theorem mappings. So, standard arithmetical, graphical, combinatorial, algebraic, analytic, topological, hybridized like algebraic topological operations are utility seeking and satisfying, which means that they're validity seeking and satisfying, where validity is synonymous with utility in a logical mathematical context, enabling dynamical refinements such as efficiency. These are, again, axiom theorem mappings from abstract relations or minimal adjoint axioms to abstract elements, namely minimal or adjoint theorems in N. So logical mathematical syntax remains in N, physical syntax remains in T. The reason why we're confused about the intrinsic mappings between physical and mathematical syntax is because, yes, left to their own devices, physical syntax is terminally encoded and therefore terminally confined, and mathematical syntax is non-terminally entangled and therefore non-terminally confined. We bridge them through QPS and ETS. Okay? So, again, even though we can draw isomorphisms directly between the STOS or physical syntax and the LMS or logical mathematical syntax, we still need to interpret and motivate these isomorphisms. Otherwise, we're just recognizing their necessary existence. What is programming and processing their necessity and their existence, right? You need perceptual and emotional levels of syntax for that. Okay. So through conspansion, axioms, whether initial or special, are generated and adjoined to N as potential theorems and, in a physical sense, as potential states. All right, type this quickly. And through telic recursion, axioms are selected and converted into theorems in N, doubling as physical states in T by virtue of physical syntax. So, once again, adjoint theorems in N, namely true statements, non-trivial true statements, undecidable truths, are the physical states in T. Okay? Adjoint axioms, meaning open-ended relations, whether initial or special, exist in N and double as the relations in T. Okay? As physical sequences. So that's, again, how we can remember the connection, the isomorphism between STOS and LMS. And I'm going to start using these acronyms, by the way, because it's getting a little bit tiring saying physical syntax, etc. So when I say STOS, I mean space-time object syntax, subsyntax. LMS is logical mathematical syntax. QPS is quality-perceptual syntax. And ETS is their unifying self-dual syntax, which we can identify with the overall teleodynamics of any system, whether it's an atomic system or a galactic system. The self-dual syntactic generation of minimal and adjoint axioms is undecidable, meaning non-mechanizable mapping from physical states to new potential states. Only its verification, once terminally encoded, is decidable. The self-dual semantic selection of minimal and adjoint axioms is, again, undecidable, is an undecidable mapping from potential states to new physical states. So, conspansion takes physical states and retracts them into new potential states, potentializes physical states. Okay? Telic recursion takes potential states in N and maps them into new physical states in T, terminally encoding them. So conspansion and telic recursion bridge STOS and LMS in this way. The axiom theorem mappings double as the sequence and state mappings of STOS, where axioms are sequences and theorems are identified as states, right? So to take a biological example, the physical end states of mitotic cycles and cytokinetic cycles must be generated as potential states or LMS relations and selected as utile physical states or STOS elements for these processes to be A, logically possible, and B, physically observable. Logically possible in N, physically observable in T. Just writing that down here. Eventually, this document will be ramified into a lengthy book length, really, publication. That's going to take some time. I really have way too many projects and personal and professional obligations to attend to, and this is not my number one obligation by any means. However, LMS and STOS alone, sort of long here, are unequipped to generate and select these cycles themselves. In other words, LMS and STOS don't generate operations. Okay? They don't interpret and motivate their own operations. So this statement highlighted in green will walk us through that. While STOS operations are responsible for physically instantiating potential states and physically parameterizing potential relations belonging to the LMS, and while LMS operations are responsible for abstractly preserving otherwise transient physical states as adjoint theorems in N and converting them into new potential states which are adjoint axioms in N, a denser syntax, namely QPS, and for that matter ETS, is responsible for generating potential operations. Okay. So actually, I'm going to write that in. Okay. So while the combination of STOS and LMS can generate and potentialize new states, thereby inducing new relations between states, namely potential and physical relations, where potential is appropriate to non-terminal domain and physical is appropriate to a terminal domain, they cannot generate new operations. Okay. So, thus far, we've self-dually formulated and elementarily related STOS and LMS. This is the physical space-time object subsyntax to review, and it is element-oriented structure. Its elementalization of processors in T occurs as 1. Physical states or bodies, remembering that there is no distinction between a physical state and a body. Okay. 2. Physical relations or sequences of states, terminal encodements, basically. Terminal encodement events. And 3. Physical instantiations, or if we want to get cheeky, reincarnations, where instantiations are incarnations, right? So they're, terminally oriented projections. That's what a reincarnation is. Of course, a reincarnation has to be defined from the bottom up so that we don't just, stipulate it wishfully into existence as many religions do. But we'll get into that later. A lot of you who are very intuitive will be sensing that we're establishing the abstract technical background for making highly intuitive statements and sweeping statements about reincarnation, the afterlife, which is a misnomer, the soul being the mapping between body and mind, referring to syntactors as body-mind-spirit complexes, referring to denser evolutionary cycles of body-mind-spirit complexes according to their self-permutations of body, mind, and spirit. Things like this, which we get into in other series, and in fact the publication concurrence, are going to be basically unquestionable, and we can actually carefully describe and unpack and apply when we have this technical abstract background. It seems extraneous, but it's not. It's quite necessary. So LMS, to review, is the logical mathematical subsyntax, which is relation-oriented structure. The relationalization, another typo, of products or properties in N as 1, minimal and adjoint theorems, reconceived as structural validations of bodies. We describe the simplest structural validation of a body coinciding with its coherent definition, meaning A body or element cannot be identical with its complement or ambient space. That's the Boolean exclusion of bodies from each other and their spaces. So that's the simplest structural validation. Of course, there are many, many other structural validations that we can actually talk about, macroscopic examples that go beyond, right, the Boolean exclusion of mutual fermionic bodies and a body in its ambient space, but we'll get into that later. 2. Minimal and adjoint axioms reconceive the structural distributions of potential bodies in the non-terminal domain. Once a physical body is instantiated, it is distributed and therefore atemporally and aspatially available to any entity in the non-terminal domain experiencing its discarnation. Okay, even though its identity won't necessarily be preserved in a stratum relative sense, it will be preserved in a stratum distributive sense. That's an Easter egg. 3. Axiom theorem mappings are structural preservations of physical states corresponding to state-to-theorem submappings and conversions of physical states into potential states, namely axiom-to-state submappings. Okay, but again, it seems like all we need are the STOS and the LMS, but what generates these mappings and submappings? We can define and describe these mappings and submappings in terms of STOS and LMS, where STOS is definition level syntax and LMS is description level syntax, but we cannot interpret and motivate or teleodynamize these mappings without the QPS and the ETS. So next, in the next segment, we will self-dually formulate the QPS. And then following that, the ETS, and then we can start to pack on more detail and invoke stories so as to balance the intellectual and intuitive aspects of our series. So I hope you enjoyed, and we will see you in the next segment. Thank you so much.